Hello all and good day. This is the competition we are trying to work on. This a Kaggle competition, toxic comments classification challenge. So Kaggle is a platform for data science competitions. And so, but we are going to consider something special about this competition. So if you can read through the competition, see it speaks about the comments online. So for us who use social media, so there's a threat of the abuse and harassment online. So it may make people to not express themselves or maybe give up even speaking on opinions. So people are very afraid of having opinion online, right? So we are going to work on the data sets and then to find out, because the competition is about finding what kind of words are in the social media platforms, whether it is about threats, obscenity, insult, or identity-based hate. So it is a multi-headed model that we're going to develop, and in this case now we are going to work on classification, but it's not the normal kind of classification we are familiar with. So we are going to look at, so the ones we are familiar with is it's actually the binary classification or multi-classification. But the binary and the multi-classification are always one level. But in this case now we are going to work on the multi-level classification. So one level classification is in the case whereby it's only one level, so there is only one target. But in this data set, as you can see from the data here now, there are 6, 1, 2, 3, 4, 5, 6, there are 6 levels we are going to consider. So it's a multi-level classification. Then the evaluation, we have to run through the 6 columns of the predictions of the classification, which in this case what they're making use of is ROC area under curve. So the value of the metric will now be the average of the individual area under curve of each of the predicted columns, which are 6 in number. So we are going to see how we are going to make use of models to be able to make predictions concerning multi-level classification. So this is what we are going to look at. I've already started running the competition already. So we are going to use a platform, the weights and biases. Weights and biases is actually a machine learning MLOps, so machine learning operations. Just as how you have in normal software development, DevOps. So this is MLOps but in this case it's for performance visualization, to have a visual representation of how your model is performing. And also you are going to track the experiments of your models. So it's actually a platform for performance visualization and experimental tracking of your machine learning models. So I installed it, it has been installed, and then I reported all the models I'm going to make use of, OS, Pandas, NumPy, and then, so like I said initially in the data sets, so for example, you see that this is the ID, this is the comment from the social media platform, and these are the columns. There are 6 of them, 1, 2, 3, 4, 5, 6, which is multi-level. So for example, the ones we are conversant with is the single level, where you have maybe like binary classification, zeros and ones, which is binary classification. If it is like 0 or 0, 1, 2 or ABC for the target column, so it's multi-classification. But in this case, it's not just only one level. There are several levels. So these are like, you can have zeros and ones here, zeros and 1 here, 0 and 1 here. So this is a multi-level classification. You might call this one multi-level binary classification, because it's actually binary, zeros and ones, whether it's toxic or not, whether it's severe toxic or not. But in a general sense, it's called multi-level classification. Okay. So this is the training data set, and this is the test data set. So I already have my JSON file for the cargo, so that you're able to have access to the data set and download it into my Google Colab, which is what I did here, and then set my paths. This is the path for the competition. So I installed all the modules I need: the transformers, sequence evaluation, TensorBoard, example transformers. So this is the configuration for the weights and biases. We're eventually going to see the platform, how it performs. So the metric we are using is evaluation loss, and the goal we're trying to achieve is to minimize the loss. The lesser the loss, the better our model performs very well. So the learning rates, the range of our learning rates is 5 to 5 raised to power 5 exponential minus 5 to 2 exponential minus 5. So the epochs, the number of times is going to be trained is within the range of 2 to 5. But this is the default. The default learning rate is 5 exponential minus 5, and the epochs is 2. So this is the data set, the data frame. So then the labels, I created the labels, and then this is the text data. So you see the labels. The labels we are talking about, multi-level classification. There are 6 of them. Use the SQL model selection, SQL model selection to be able to divide my data sets. And then this is the function that does the multi-level classification. We are going to import the multi-level classification model from the simple transformers classification, and then we are going to train it, and then we get our results. So the computer is currently running. This is the first part of it. So there are several of the models we are going to train, and then we are going to compare them in the weights and biases platform. So the very first one that's already worked on is this Rosie and Sweep. It's already trained it. Our training loss is 0.10427, and the global step is 15,000, and the learning rate is 0.0. It continues running. This is the second one, and then the third one is currently running. So look at the platform here, the weights and biases here. So the Rosie step is this, the one in the blue color. Why the second one is the treasure step? So we're going to consider this one. You see, the global step for the Rosie step is 15,000, which corresponds to what we have here. For the Rosie step, 15,000. Can you see that? And then the training loss for the Rosie step is 0.1043, which is approximately equal to what we have here, 0.10427. Here is it. If you approximate it, is 0.1043. And then the learning rate for the Rosie step is almost 0, actually. Almost 0. Unlike the treasure step, which is 0.0000239. The final learning rate for the Rosie step is almost 0, which is similar to what we have here. So it continues, but what I wanted to emphasize is we can have multi-level classification where you have not only one level but several levels. It's a bit difficult compared to the single level classification, which is the binary classification and the multi-classification, but it can be worked on. It can be trained on. You can work on that using this module, multi-level classification. So if you have any feedback or any suggestion concerning this, you can put it in the comment section. So I just wanted to show an example of the kind of problem that requires multi-level classification, different from the normal one which we have, which is the single level, which is the binary classification.